Let's take a look at the process for finding the derivative of an inverse function. And I've got a simple one here. I've got f of x equals x squared on the interval 0 to infinity because I want it to select an interval where the function is 1 to 1. In other words, where we could find the inverse. Now, I want to go through the process and just find the inverse, and then I'm going to take the derivative of the inverse. So let's look at this. I've got y equals x squared. Remember, you interchange variables. Okay, so I swap the x's and the y's, and now I'm going to solve for y. And y equals the square root of x on that interval. Okay, so I don't do plus or minus. I'm talking about 0 to infinity. Now, let's just think about what we have here. We have f of x equals x squared, and we have its inverse, which is the square root of x on this interval. Now, notice that this function has this point 2, 4, and of course the inverse would have the point 4, 2. See? So we have 2, 4, and 4, 2. Now, what I want to do is I want to find this. I want to find f inverse, the derivative at 4. I want to find this. I want to find the derivative of the inverse of f at 4. That's what I want to do. Well, I can just take the derivative of this function right here, right? So it's easy for me to find the derivative of this function. Okay, so let me just go through there and do this. It doesn't require anything special. I've just got 1 over 2 square roots of x. That's the derivative. Now, having found the derivative, I can then plug in. So I can plug in this 4. Which is just going to be 1/4. That's going to be my answer. Okay? Now, so that tells us, so this kind of, I'm going to come back to this because we won't always be able to do this. In other words, I could find the inverse of x squared, and then I could take the derivative of that inverse and then just plug in. We won't always be able to do that because finding inverses can be more complex than we found in this problem. So let's just suppose that we've got y equals f inverse of x. And what I want to do is I want to find the derivative of this function. I want to find dy dx. That's what I want to find. So let's think about how we would do that. Well, let me apply f to both sides. So if I do that, I get f of y on this side, and on this side over here, I just get x. See? I just applied f to both sides. Now, let me take the derivative. Well, I need to use the chain rule, and I'm going to use implicit differentiation. So here's what happens. I have f prime of y, derivative of the outside, times the derivative of the inside equals 1. Okay? Now, I'm trying to solve for y prime, so let's see what I have now. I have y prime is equal to 1 over f prime of y. Now remember what y prime is. Y prime is the derivative of this inverse. So we could rewrite this as f inverse of x prime okay, equals 1 over f prime of y. Yeah, like that. So this is kind of a quick formula that we can use to find the derivative of an inverse function at a given value for x. Okay, now let's look at a particular example here. Let's suppose that I've got f of x equals x cubed, and let's say plus 2x minus 1. Let's suppose we've got something simple like that. Now, I want to set this problem up by finding f of 1. Well, f of 1, if we put a 1 in here, this would be 2. So on this function here, we've got the point 1, 2. Yeah, see? So if I put that 1 in. But what about the inverse? Well, the inverse function is going to have the point 2, 1. Yeah, see? So you swap those. Now, you can't hardly see. Let me write this a little better. F inverse. Okay? Now, so I've got this point. Now, here's what I can do. I can find F inverse of 2. I can find the derivative of that. I can find the derivative of F inverse of 2 this way. Notice I've got the 2 here. That's the x. Now I'm going to put 1 over 3x squared plus 2 for x equals 1. And actually, let me write that a little differently. I'm going to have 3y squared plus 2 for y equals 1. And here's what I'm going to get. I'm going to get 1 over, in other words, I'm going to take the derivative of this function, but I'm going to put in the y coordinate. See, I take the derivative and evaluate it at the y. So here's what I have. I have 3 times 1 plus 2. That's 1 squared. And that's 1 over 3 plus 2, which is 1/5. And there's my derivative using this formula.